Hello and welcome back to a new video in my C++ tutorial series. In the last video we had separated our code into a library and an executable, which both got linked together during compiling, or actually during linking, to generate one big exe. And what I also told you is that we have the option to create a dynamic library. So a library that is not linked during linking, but a library that gets linked during runtime. However, to understand this and to know how this works, we need to first understand how the preprocessor works. And that's not the only reason why we're talking about the preprocessor. We're actually going to talk even more about the preprocessor and even explore more things that it can do than what we need for the dynamic library. And we are doing this because the preprocessor is a very, very powerful tool. The preprocessor's purpose is to alter your code before it gets compiled. That's the main reason, and we already use it, but you're going to understand this after this video. So a preprocessor alters the code before we compile it. This is also where it comes in our toolchain. It's the first thing that happens. This is because it's called the preprocessor, or this is actually why it's called the preprocessor, not because, so why it's called. So the idea is basically that before we are compiling our files, remember every C file goes through the pipeline, not the header files, just the C files. And before we can actually compile that C file, because there are many things missing, like all the information stored in the headers, we need to first preprocess it and move all the code from the headers into our actual Z file, doing this of course virtually, not moving this physically, doing this virtually in memory so that we can then start and compile everything and have all information available. That's all done with the preprocessor, and we already use the preprocessor. So let's jump directly in the code and look what the preprocessor does. So a few videos ago I told you that everything that starts with a hashtag is for the preprocessor. And you can see here we already have hashtags in here. For example, I'm currently taking a look at the main.c file. So the hashtag is basically a directive for the preprocessor, so-called preprocessor directive. In this case, it's a include directive. It's always called directive, like this is a function and stuff like that, but everything for the preprocessor is kind of like a directive. Everything with the hashtag, it's a directive, not a function, not an expression, nothing. It's in a directive, because directives, if you talk about directives, it's always preprocessor directives. So that hashtag include, what is that doing? We already talked about that. This is copy pasting the contents of that file in here. So if we include ini-parser.h, it opens up the ini-parser, copies all the data, and moves it into that line. Of course, not physically, it's doing this virtually in memory to then compile it. Now, one thing that you might have noticed is that inside of the ini-parser there are also preprocessor directives. This basically means that the preprocessor is kind of like running recursive. So it's basically when it finds the include directives, it goes to that file, tries to preprocess that file, then it finds another include directive, it then preprocesses first that file, and as soon as it kind of like has finished preprocessing a file, it's then going back and pasting all that content virtually together. Now this is one preprocessor directive that we found, that copy paste that file. Now, this is another preprocess directive, the pragma directive, and the pragma directive was kind of like invoked with that once, and we already talked about that one. This is kind of like putting a brain into the otherwise brain-dead preprocessor. Otherwise, if it's brain-dead, it's going to copy everything, and if you have like a hashtag include directive here, and you already included that, it's brain-dead and will copy it again, because it's not intelligent, and it would also even follow down the rabbit hole and would go into a loop if you have a loop in there. If you would, for example, in stdio include stdint and then stdint stdio, then it would kind of like have that loop and things would break. So the preprocessor is really a dumb application. This is kind of like putting a bit of a brain to it, and we're gonna explore actually today how this works by showing you the different option, how we can do this as well, which is like the older version, and you shouldn't use it yet in your applications. These are the two preprocessor directives that we have known, and they are holding up to what I told you. They are modifying the files before we compile them. They are copying all of the headers into the big single C blob. And this is what it does. It modifies the code. It modifies it before it gets compiled. Now, this is one usage of the preprocessor, and like the most common one, that you are including files. Now, the other use case of the preprocessor is to generate code on demand, or to alter code on demand. How can you alter code on demand? Well, you could retype it. This is one thing. You could always go in and change something. However, you might not want to change something by hand. For example, we have this debug and release switch. When we are on debug, we might want to have some additional output. We might want to, inside of the INI parser, might print a debug log and say, all right, now I have found a key, now I have found an invalid value, and output some debug information so that we can see that if something is wrong, we can directly see what is wrong. But on release, we don't want to have these debug outputs. And how can you solve this? Well, you could do a Boolean value at the start of your application. So int is debug. And you can set this to 1 if you're debugging, and as soon as you're releasing that, you put this to 0, and then in your code, you're always going to do an if is debug. Drawback, you need always to pass this if around, that is going to be messy. Now, this is something that the preprocessor can actually solve. The preprocessor can solve that that issue that you only want to have something on debug and on release. And this involves defines. Defines are the second power of the preprocessor additionally to the includes. The defining is kind of like a variable system. You're defining a variable, kind of like a name. You do not really call it variable or something like that. You call it define because it is a preprocessor definition, a define. And basically what you can do is you can define this dynamically. And dynamically doesn't mean that it changes at runtime, it just means at compile time. So what you can do is basically say, on debug, I want to have a specific preprocessor define. Actually, by default, we already have one. It's called just underscore debug, that one on Windows. If you are taking this one, if I hover over that, you can see this is 1. This is already kind of like how the preprocessor works. Like this define is only there on debug. If I would switch to release here, this will no longer be found. As you can see, it's getting gray and says error type and no longer finds the number. This is actually a define of the preprocessor. So the preprocessor has defined this underscore debug define during only during debug builds. And this is how Visual Studio rolls. Visual Studio by default does that for you. Now, this is actually one step ahead. Let's actually take a look on how we can define something. How can we define something? We're going to write an hashtag, because hashtag is the kind of like keyword for the preprocessor, or the actual key sign for the preprocessor to jump in and take a look at that expression. So as you can see, we already have the define keyword here. So hashtag define. So probably we're going to use define to define something. Now, how are we going to define something? Well, we're going to type in the name. And as you have seen with the debug constant there, this debug define, we are always writing them in caps. This is just good practice. If we are dealing with the preprocessor, we're going to always write everything in caps. And if we have kind of like something like my name and you want to have the my separate, which we earlier did so like that. So earlier we did this like that. Same with our function names. I like that style. However, on the preprocessor, since this is all caps, we are going to use underscore. So I could like define my name. So how would I define my name? Well, I could write Ludwig like that and do it as simple as that and say, right, my name is Ludwig. And can we use it? Well, actually we can. I can put this everywhere in my code and I'm going to have Ludwig available. So if I put this in here, I have Ludwig here. And if I hover over that, it says expands to Ludwig. And then it also says the error here is identifier Ludwig is undefined. So yeah, basically what it done, it has copied and pasted Ludwig in here. And Ludwig is not a C expression, it's whatever it is. No, I don't want to search for my name. And it cannot really handle this. And this is because this is just a plain text Ludwig. This is not a real variable. This is not a string. This is actually nothing. This is just a text that gets copy-pasted in our source file. So if I would want to have that as a valid string, I would need to get the Ludwig into strings. And if I do this like that, you can see it's no longer an issue. Now we have the issue at the if, because it expects a semicolon. So if I would add a semicolon here, then this is totally valid. And we have here expands to Ludwig. And now to make this even better, I could say like const char name equals my name. And if I would do that, make a breakpoint here, make sure that I am on debug and start the application, you're going to see that the name variable contains the string data for Ludwig. And now we are fine. Now we have defined something with the name Ludwig. How can we use it? Is it useful? Yes, we can. We can do this, for example, if on debug I want to have a different name. So I want to have the debug Ludwig and the normal Ludwig. How could I do this? Well, I need to check if the debug define that is been introduced by default. I'm going to show you in a second how you can do this with Visual Studio as well. So if you want to have this debug default or want to check for the debug default, you need to kind of like write an if, right? If the debug is defined, then do something. And this is how the preprocessor actually works. We can actually say if. Now, as you can see, we have 3 versions of that if. We have the normal if, the if def, and the if nadef. The ifdef basically checks if something is defined. In this case, it checks for normal debug. That's not how we want to have it. I actually want to have it ifdef underscore debug, because this is how Visual Studio rolls. So you're going to say debug Ludwig. And now I, of course, need an else as well, because if I would just end this up with an end if, on debug, it is fine. It's going to find that my name. But if I would now switch to release, which you can also see that now, as soon as this debug is no longer defined, this is grayed out. So it's no longer defining here. And of course, you're going to have an issue here. My name is unidentified. And of course, I can like now say else hashtag define my name is Ludwig. And we are set. Now we could start out and greet Ludwig. How can we greet Ludwig? We can do a printf. Let's use the safe version here. We can say hello, and then I want to say the name as a string, and an exclamation mark, and a new line, and then I'm going to say my name here. So like that. Of course, I need to write printf correct. Printfs hello, my name. Now, if I would run this on release, we are getting the hello Ludwig exclamation mark here. Now, if I switch back to debug. Wait a second here and scrub, I would now think that I get the debug Ludwig. And surely enough, hello, debug Ludwig. So what we have now done, we have dynamically altered the code on debug or release. And this is kind of like how the preprocessor works. Now, I told you that I'm going to show you where this debug is defined, and surely I'm going to show this to you. If you are right-clicking your project here on the right and go to properties, you can define the defines inside of CPP, preprocessor definitions. You can see that there are different options, because on all configurations and all platforms, these are going to be different. They are actually dependent on both of them and dynamically generated with information about the platform and the configuration by Microsoft by default. So if I would switch this to debug in Win32, for example, you can see that by default is defined Win32 underscore debug underscore console. We don't really care about all of these things. We just care about all of configurations, and I could now go in here, go to edit, and then define something. For example, I could define my debug to basically indicate that we are debugging. Now I'm going to say OK. It works on all configuration, all platforms, just don't remove the different options if you are inside of dialog. Hit apply, hit OK, and now I could check for my debug. Now, of course, my debug is always going to be there, no matter if debug or release. To fix that, we would need to make this properly, and I didn't sort of making this properly. So what I'm going to do here now is I'm going to remove that from here, make sure that we just have the different options in here. Then I'm going to go to debug here. Then I can just add these with the semicolon here, hit apply, and OK. And now on release, we don't have debug. And if I go to debug, we have debug. One thing that I always like to make sure is when I'm done with that to switch this back to all configurations, because I tend to forget this as well. So now we have my debug, and we have an own custom debug switch in here. Yeah, nice. That's nice. Now, what I also want to do is I want to actually modify that printfs. This printfs is actually printing my name and is greeting me. However, I do want to write an own greet function that works different on debug and release. How can I write a greet function that is different on debug and release? Well, we're going to write a preprocessor function. The preprocessor allows a definition of functions, and I'm going to call the function now my greet. Now, this is actually now written like a normal function because it's intended to be used as a normal function. So how I'm going to do this? Well, if I want to greet somebody, I need his name. So my greet requires a name. Now I'm just going to steal that one here, and we're going to modify this. So if we are on debug, I want to say debug hello to my name. Not my name in this case, just the name that has been given here. So even through this preprocessor is doing like just copy pasting, it still can handle functions. So basically you're giving it a function name and parameters. It's then going to copy paste this in by replacing the name with the actual data that the user has given it here. Now I of course need to do this for release as well, where I'm just going to greet it with a normal hello. Now instead of the printf down here, I do actually want to greet me with the myGreet function and the my name in here. And if I would hover over the myGreet now, you can say that this now expands to printfs underscore debug hello, comma debug Ludwig. So this is actually replaced on compilation. So if we are compiling, or actually before compilation, during pre-processing, this is actually replaced. This is not a function call like we had it previously. This is just replace, copy and paste with the actual data that was required. So if I now switch to release, you can now see that it now expands to hello Ludwig. So it's dynamically changing based on the definition. And now you think, what is really simple? How can we do something that's only done on debug? I can define something like debug only expression, and on debug I'm gonna use the expression, and if I'm on release I can basically just say something like that, which is gonna do nothing. And if I would now use that, for example, here and say printf test 1 2 3 debug, I'm going to make a new line here, and of course I need to close this up with a semicolon. If I would do something like that, and I am on release, I just get my hello Ludwig, and if I now go back to debug, wait a second, you can see it's getting yellow now, and if I would run this now, I'm also going to get the print. Okay, I've written printf wrongly, so now I can see that works. Test 1 2 3 4 debug. So for example, if I just want to execute something on debug, I can use it like that: debug only, printfs, test 1 2 3 debug. And you can actually see while we are on release, actually I can write everything in here. I can say like cock_printfs, and if I would run this, it cannot find the function, of course. But if I go back to release, it's not going to have a problem with that, because the preprocessor deleted it before we actually get into the compilation. So the compiler did not even reference this cock_printfs, so it wasn't an issue during compiling. So this is really a hard text copy. Not a hard one because it's done virtually, so it's like the soft text copy, but it is a copy pasting of text around something. How could we bring that into use for our application? Well, we can actually define how which format should be enabled by default. Let me quickly remove the my debug. I don't need this here. Let's clean this up, what I've done wrong. Or not wrong, but unintentionally. So what I could, for example, now do is I could now check for which format function I want to use by default. How would I do this? Well, I basically have two switches that I can do. I can say like ini explorer. I always like to prefix them so that we don't get collision with other defines from maybe a library. So you should always prefix this with your application name, like ini explorer, for example, like that. It's always safer if you do this like that. And I could say now default format 1. Default format 1 or default format 2. One of them should be defined. I'm going to define both of them, and we're going to now try to catch them if we define both of them. Well, how could we do this? Well, we could do and say if def, if defined, that one, and if, then we want to do something, and then we can say if ndef, not defined. If not defined that one, then we want to do something, and we want to define x2, or let's not define x, let's call this default, or let's now just call this format callback, and then I can say format callback is that data ready 1. And now, of course, I need to also check the error case, so I would need to say else. If that is defined here, actually, then I want to throw an error because both were defined, and I can do this by just writing error and say both formats can't be used, something like that. And this error directive basically just outputs an error in here. Error directive, both formats can't be used, and we directly have an error, what's going on wrong. However, this is looking very ugly because we would now need to copy paste this again, and this is gonna be getting a big mess. This is why the preprocessor now supports a nicer if. The nicer if works like that. You can write an if, just a simple if, like an if directive in C. Then I can write defined, and defined checks if something is defined. So this one is now checking if that is defined, and if I would add an end if in here, you can see that this would work. It's defined, so it would go in here. Hashtag define. Oh, now I deleted that I didn't want to delete this. Format callback is that one. Now I can check this very simple, and it works. Now, of course, I also need to check that the other one is not defined, so I can say a not defined, same syntax than we have in C, and it's gonna go in here. Now, else if is also possible. It's called elif here, and I would check if the tier 1 is defined and not defined is the first one. And if this is the case, we want to define the callback to the second callback. Now we just need a global else, which is going to give us the error, and it says, please define only one, please define exactly one default format. So this is now giving both error cases. We need exactly one, not 0, not both of them. So if I would now comment out the second one, it should go in the first one and set this to the INI data ready 1, which is this doing. If I comment out both of them, it should go back to that error. Yeah, it's doing that. If I now uncomment the format 2, we are going to the format 2 and everything is set. Now the only thing left to do is to get this into our project configuration by going to the INI Explorer, and I can go in here and do this on my favor. For example, on debug, I want to have the format 1 here, hit apply, switch to release, and on release, I do want to have the format 2. Now I can hit apply again and OK, and you're going to see I'm on the release, it's taking the format 2. If I go to debug, it's taking the format 1, and it's dynamically setting them depending on which configuration I am on. Now, of course, we need to put this to use and alter our code. So let's copy this callback here and set it by default now to that one. I also want to change how this works because this is no longer working. Now I can't just look for the 2. I also need to look for the 1. And if I'm doing this, I can do this now properly and not as hacky as I have done this previously. So what I now want to do is basically I want to do a switch. On what do I want to switch? I want to switch on dereferenced arg v2, I think was it? 0, 1, 2, yeah, 1, 2. And dereferenced, so I get the first character, and the first character can be the 1. If the first character is the 1, I'm going to set the callback to the callback 1. Break in here. Copy this again. Set this to 2. Data ready 2. And then we're going to have a default statement here. And by default, I'm just going to do a printf and say invalid format, like that. There we go. So I say invalid format, and then I'm going to return a -1 here, like that. And now we should be ready, and this should work. Now on debug, we should get the first format, the bigger format. If I run this, let's see. Yeah, we're getting the full output. If I go to release, wait a second, until Visual Studio takes it in. Yeah, I'm getting the smaller output and it works. Now let's quickly check if release also works directly from file. Let's see, the INI parser. No, I actually want to go to the output folder. Let's go to the release one. Let's open up a CMD. And let's say INI explorer.exe. Okay, so we need the file path. If I now take the full path to my config.ini, paste it in here, we should get the small output, and now if I select 1, we should get the big again. Yeah, works. Doing a 2 here should get the small as well. If I do a lol here, invalid format. So it's working as desired, and that's the whole magic of the preprocessor. Oh, I also told you how the pragma once works. Actually, pragma once is something like that. If not defined, my, or let's just call it INI parser._h for INI parser header. So if that header is not defined, I'm going to define that header, because as soon as I include this once, this needs to be defined, and then it will be defined. And at the end, I'm going to do an endif. This is actually what the pragma once is doing. It's automatically figuring out what the name of that is, and it's doing this a bit more reliable than just the name that could be like 2 files having the same name. If somebody has a file called util.h and they are just checking for util_h, then things are going to break, and you're just going to be able to include one header, even though the 2 libraries have the same file, but different defines in, same defines in here, even though the files are different. But this is basically what pragma once is doing. If it's not defined, define it, add all the content, and if we include it again, it's already defined, it will skip everything. That's basically what these preprocessor defines can do, because basically you can put everything in between these preprocessor ifs. You can put code in between them, you can put header things in between, and you can really do everything. You could do everything in here. You don't just need to put defines into these preprocessor directives. You can put code in between them, everything you desire. You can put this in between preprocessor defines. If it's C code, everything, comments, you can actually stripe out comments. Even this wouldn't be a point in striping out comments, but that's how the preprocessor rolls it. It's basically working on the raw file. It's not in the context of C, not in the context of the preprocessor. It's really operating on the raw file itself. And that's the magic of it. And that's what we need for understanding dynamic linked libraries. Thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.